So we're looking at rational zero theorem. So if you remember, if we have a polynomial function of degree n, then it's going to have n number of zeros. So if it's x to the fifth, it should have 5 zeros. So okay there? All right. So the real zeros can be either rational or irrational, which means they can be written as a fraction. So we're going to get problems that look something in the form of p over q. And of course, q is not going to be able to be 0, obviously. All right, so with the rational zero theorem, we can find all these zeros. So we've kind of seen this before. This is just a demonstration of a lengthy polynomial function that we can keep raising the power. So the p are going to be the factors of the constant term at the back. And then q, so that would be like your a sub 0 back there. Then q are going to be factors of the leading coefficient. So a sub n up front. What this allows us to do is to try to see what we can divide by, because before we were given, like, they're like, divide by x plus 1 or whatever, and we would divide it out. Well, here they're not going to tell us in advance, so we have to kind of figure out where do you start. So if I look at my 2 back here, that is my p. So my p value then can be the factors of 2, which would be plus or minus 1 and plus or minus 2, because negative 1 times negative 2 gives us 2, and positive 1 times positive 2 gives us 2. So it could be either one. My values for q out here out front are going to be obviously plus or minus 1. So if I look at all of the options for p over q, then p would be 1 over 1 and or 2 over 1. Does that make sense to y'all? So therefore p over q is going to be plus or minus 1 and plus or minus 2 since they're over 1. So if we look at 18, like obviously when this is 1, I'm not going to write q out all the time when it's 1, so it's kind of a waste of time. So for 18, I would have plus or minus 1, 2, 3, 6, 9, and 18. Technically, they're all plus or minus, but I'm not going to write that every single time. All right, and then for my q, all of those would be 1, right? So essentially, it's going to be all of these would be my p over q. Are y'all all right with that one? Okay. So then when we get one where we do have a leading coefficient that's not 1, then that looks a little bit different. So p obviously plus or minus 1 here. So this is my p right here. So then for my q, I'm looking at plus or minus 1, plus or minus 2, and plus or minus 4. So when I look at p over q, I'm going to have whole number 1, right? 1 over 1. But then I'm also going to have the halves and the fourths. Is that logical to y'all? So I'd have plus or minus 1, plus or minus a half, and plus or minus 1/4. Obviously, we wouldn't want to start with the fractions if we don't have to. We'd try to start with the whole numbers first for synthetic division. Because that's what we're looking at, is we're finding what we could possibly synthetically divide by to get a factor out of there. Is that logical to y'all while we're doing it? All right, so if we look at 16, that would be plus or minus 1, 2, 4, 8, and then of course 16. And then I'm going to write it this way. My q's on the bottom would be plus or minus 1 and plus or minus 3. So if I put all of those over 1, all my whole numbers stay. So I'm going to have plus or minus 1, 2, 4, 8, 16, but then I've got to put them all over 3. So I would also have third, 2/3, 4/3, 8/3, and 16/3. Those would be all the possibilities that could be factors of that. Or actually solutions, not really factors, but we can turn them into factors. Y'all okay there? Okay, are y'all okay if we skip these next two and we kind of move forward with what we're gonna do with it? Like y'all are okay with finding P over Q? Yes? Okay. So, how we're gonna use this is we're gonna find P over Q, and then we will synthetically divide until we find a factor that we can then move forward to factor the thing all the way. So if I look at this one right here, I'm gonna have plus or minus 1, 2, 4, and 8. Q is 1, so I really don't have to worry about that. So we're gonna look at where do we wanna possibly synthetically divide. So do you wanna start with, we can start with positive 1 and try that, because that's really all we can do. It's just kind of a trial and error. Are y'all following? Okay, so if I divide by, let's say positive 1, now I would have 1, 3, -6, -8. So that would be 1, 4 would be -2. Alright, that's gonna be -10, so that one doesn't work. So 1 is not one of my solutions. So I'm gonna try -1. And unfortunately, there's not really a quick way to go about this. You just have to try them until you find one that works. So it gives -1, 2, -2, -8, that's +8, that's 0. Okay, so -1 is a factor, is the solution, which means x plus 1 is a factor. Y'all okay there? So once I have that, then I can do what we've been doing already, which was I can take my x squared plus 2x minus 8, and I can factor that, which looks like +4 and -2. So then what they want us to do is list all the possible rational zeros. We did that. Find the actual zeros. We've done that. So my factored form is x plus 1, x plus 4, and x minus 2. That's my factored form. And my solutions are -1, -4, and +2. And they didn't really ask you to write the factored form there, but sometimes they do. So if they do, just make sure you write them out and you don't forget the first one. Y'all okay there? Alright, so let's see, 8's pretty straightforward, 9's pretty straightforward. 10 also pretty straightforward. Do y'all want me to work another one of those so y'all can see how this works, or y'all are okay? Want me to work another one? Let's look at 10 since it has some fractions. Y'all okay with that? Alright. So we'll go down to 10. If I look at my 6, I've got plus or minus 1, 2, 3, and 6. Then my denominators are just 1 and 2. Plus or minus 1 and 2. Alright, so all my whole numbers exist, right? So we've got those 1, 2, 3, and 6. And then when I put them over 2, that's going to give me a half. This becomes 1 again. I don't need to write it a second time. You okay there? So then this would be 3 halves, and 6 over 2 becomes 3, which we've already got. So you wouldn't write them twice. Everybody okay there? All right. So I usually just start with +1 and go from there. There's really not anything you can do other than just trial and error. And sometimes it takes a while. So if we start with +1, we have 2. -5, -1, and 6. Don't forget, if you're missing a place style, you don't forget we gotta put a 0 in there. We don't have it in here, but just in case. So that gives us 2, -3, 3 should be -4. That one's not gonna work. As soon as you see it's not gonna work, you can stop. You don't have to keep going. 2, -5, -1, and 6. 2, -2. 7, +7, +6, -6, 0. Okay, there it is. Alright, so this would be x plus 1 worked again. So So we've got x squared minus seven x plus six. So it looks like x minus one, x minus six. And I'm just gonna write x plus one behind it and write my solutions underneath. Plus or minus one and positive six. Oh no, I factored that wrong. Y'all didn't catch me. Lily, you usually catch me. There should have been two there. I just now saw it. Sorry, y'all. My fault. There should have been two there. Which would have meant x squared minus 7x plus 12. I'm sorry. Minus 4 and minus 3. And then pull the 2 back out. Okay, so this one becomes x minus 2. And this one becomes 2x minus 3. And then I'm going to add my x plus 1. And then I'll write my solutions underneath. So I've got, it's like negative 1, 2, and positive 3 over 2. And all of these should be in my original list that I had, and they are. Y'all okay on that? Y'all want me to work another one, or y'all are okay with how to do it? Pretty straightforward.